Hello everyone, myself Ami Mehta, and in operating system, let us discuss what is I/O buffering, input-output buffering. So, what is the basically concept of buffering? So, perform input transfer in advance of request being made and perform output transfer sometime after the request is made is called buffering. So, basically, this is the concept of buffering that operating system perform input transfer in advance of request being made. Means before request is made for some input value, the transfer is already happened, and after request of output transfer, that after some time of request, this operation is completed. So this is the concept of buffering, and why it is happened, let us discuss that. There is a type of I/O devices. The first is block oriented. So a block oriented device stores information in blocks that are usually of fixed size, and transfers are made one block at a time. Generally, it is possible to reference data by its block number. Hard disk, floppy disk, and optical drives such as DVD-ROM and CD-ROM are example of block-oriented devices. So, these devices are stored information in particular number of blocks. For example, which is a fixed size. This is a block 1, this is a block 2, this is a block 3. So that way, in that manner, it will store the memory, or we can say that it will store the data. Generally, it is possible to reference data by its block number, that 1, 2, 3. Now, what is the concept of stream oriented? This is the block oriented. Now, in stream oriented device, transfer data in and out as a stream of bytes. So likewise, this is 8 byte stream, 16 byte stream. There is no structure of block. So terminals, printers, communication ports, keyboard, mouse, and other pointing devices, and most other devices that are not secondary storage are stream oriented. So these are the stream oriented devices, while the secondary storage devices like hard disk, tape drives, these all are the block oriented devices. Now how and why I/O buffering is required? So first we discuss what happens there is if we are not using a buffer. So this is without a buffer, operating system directly access the I/O devices when it needs. So this is the operating system. There is no concept of buffering. I/O devices. For example, user process wants some input and want to some write or want to some print. Operating system directly access the input-output devices when it is required. But now, if there is a concept of buffer, what happens? Operating system does not directly access the input-output devices request via main memory. In single buffer, operating system assign a buffer in the main memory for an I/O request. So in main memory there is one buffer, and now operating system actually assigns some portion of memory as a buffer. For example, from 2000K to 2050K there is a buffer. So this particular portion is assigned by operating system as a buffer. Now I/O request is handled by this single buffer. Now what if there is a double buffer? So operating system use a two system buffer instead of one, also known as buffer swapping. A process can transfer data to or from one buffer, while the operating system empties or fills the other buffer. So operating system is busy in with task with one buffer, that they are filling or they are empty that buffer, but input output operation is handled in another buffer. So so that there is a concept of double buffer. So while using one buffer is they both all the task is handled in one buffer. But now there is a double buffer, so a process can transfer data to or from one buffer. So this task is continuing while operating system busy with empty or fulfilling the other buffer. So this is the user process, the consumer. So this is the move and IO devices are entering in this buffer. So the parallel processing is occurred while there is a concept of double buffer. Now the next one is circular buffer. Operating system uses two or more buffers. Each individual buffer is one unit in a circular buffer. So this is work as one unit used when IO operation must keep up with process. So this is the concept of buffering, how single buffer, how double buffer, and how circular buffer is used by operating system to handle processes and input-output devices. Now let us discuss what is disk arm scheduling algorithm and the concept of disk arm scheduling. So first we discuss the definition and internal structure of hard disk. So when the disk drive is operating, the disk is rotating at constant speed. To read or write, the head must be positioned at the desired track and at the beginning of the desired sector on that track. So the structure of HDD is like this. So whenever we want to read or write some data, it will be on the desired track and in desired sector to read some data, and at the same time to write some data it will be on some desired track as well as sector. So track selection involves moving the head in a movable head system or electronically selecting one head on a fixed head system. So there are two types of system: fixed head system and movable head system. If it is movable head system, in track selection procedure, moving the head is required. And if it is a fixed head system, we have to electronic or in that system electronically selecting one head for particular reading or writing operation. On a movable head system, the time required to move the disk arm to the required track is known as the seek time. But obviously there is some time required to move particular cylinder to assign some track or to positioning track. So on a movable head system, the time required to move the disk arm to the required track is known as the seek time. The delay waiting for the rotation of the disk to bring the required disk sector under the retrieved head is called rotational delay. So these are the terminology in the concept of HDD. What is rotational delay? What is seek time? So but obvious to move the disk arm to the required track is known as seek time, and for rotating the disk to bring the required disk sector to keep track there is a seek time. To keep disk sector there is a rotational delay. So but this is a read write head, so this disk is moving and to particular bring some track onto the read write head, and that time is called seek time, and to bring some sector into particular read write head is known as rotational latency. So these are the various disk arm scheduling algorithm: FCFS, SSTF, scan, C-scan, look, elevator, C-look. So these are the various steps of disk arm scheduling algorithm. Let us discuss one example for the disk arm scheduling algorithm. Now we have to consider an imaginary disk with 51 cylinders. A request comes into read block on cylinder 11. So for example, some read operation is required on the cylinder number 11. There are total 51 cylinders. So in this, there are total 51 cylinders. Now, there is a request of number 11 cylinder. While the sector cylinder 11 is in progress, new requests come in for cylinders like 1, 36, 16, 34, 9 and 12 in that order. So now 11 is in the process. But now there is another request like 1, 36, 16, 34, 9 and 12. So starting from the current at position, what is the total distance in cylinders that the disk arm moves to satisfy all the pending requests for each of the following disk scheduling algorithm? So there is a need now. So this is the need of, there is a need of which algorithm we are using. So this is the concept of what is a disk arm scheduling and why it is required, the definition. Okay, and there are various, these are the various steps of disk arm scheduling algorithm that we will discuss in next session. Okay, so in this session we discuss how input output buffer is required and how operating system use it and what is the concept of disk arm scheduling algorithm. Thank you.